Good afternoon, everyone. Today, I am Hemant Kumar. Today, in this webinar we are going to be discuss basics of the solar energy and how solar energy will implemented and in generation technologies. So, without any delay, we can go for the introduction. In this session, we are basically aware about the solar energy and also types of solar energy and also some of the solar energy technologies, that is photovoltaic solar energy, and also some photovoltaic solar energies that is implemented, and also applications for that solar PV system in this webinar. So first of all, this solar energy introduction, that solar energy, it means that solar, it is comes from the Latin word. Solar means sun, and is a Latin word, and it is means that energy absorbed from the sun. It will be in different types of energy formations like heat, and also like in electricity, and also from like thermo like liquid heatings. So that solar energy will be when this is come from the sun. So sun is this free energy of source. So we don't require anything for the sun source. So it is a you can again you can use this energy for again and again for every day, in everyday life cycle. So from morning to evening, that solar sun is available, so we can generate the energy from the solar. So basically, that solar rays will strike the surface, so it will generate the radiation. It will generate the radiation that absorbed by the earth, that will convert into the heat or electricity. So that radiation absorbed by the earth, it is like it will be in, but we can get the more energy from this solar light, like sunlight. It will be in perpendicular to the earth surface, then only we can get the maximum energy. So if it is not in perpendicular, so we are not get that gain from the sunlight. So always that we have to collect the sunlight will be that collecting mechanical device that will be perpendicular to the solar light. So each solar energy, it is comes under the renewable energy. These are the energies that from the non-fossil fuels, like the natural resources like sun energy, that is solar energy is the solar and sun energy, and also wind energy, it is comes from the wind, and tidal, it is it's another concept, like from sea tides we will get the energy from there. And biomass, it is street wastages like food wastages, and that's one. And hydroelectricity, it is from the water, that water will turn the turbine, and then the turbine will drive the generator, so we can produce the hydroelectricity. So these are the non-fusion fuels, and also this is a renewable energy, you can call it. It's non-renewable energy, that means it is from the fossil fuels like coal, gas, and oil. So basically, these are all the coal, gas, and oil are the fossil fuels, and it is always have to get from the other sources, like it is very much available, like mineral. It is mineral fossil fuels. So coal, gas, and oils are the very expensive as compared to the solar energy and sorry, renewable energy sources. Like coal, gas, oil is we are getting from. It is we need to get it from costly, and that is sun is free of sources, like sun and wind are free sources of energy. As I said in before starting the session, so like in the introduction, that sun rays strikes the earth space at the various angles, like it is 0 to 96. If surface is 0 to 90 degrees flat, so always you can remember the sun ray strikes at vertically, so it will be in particularly perpendicular, such as that strike in directly to the sun rays directly to the solar panels, whatever panels are solar thermal heaters. So it will gain the maximum energy from there, and it will generate the heat or electricity. So as per the MNRE, that in India, it's per year we are receiving 5,000 kilowatt hour, 5,000 trillion kilowatt hour per year is received in India alone. That means we are getting a maximum power because it is comes under the our India is having radiation will be high in India. So maximum locations in India receive 4 to 7 kilowatt hour per square meter. That means it will generate in square meter location. We can generate 4 to 7 units. Like kilowatt hour is means it is definition will be the like it is generation energy, that is generation power in 1 hour. So it is calculated by the MNRE recent studies. And we can go for the advantages of solar energy. Solar energy is a free of cost. It is you don't require to buy anything any from there, and it is free of cost and free of source. You can use anywhere with some precautions. We can use anywhere and we can get treatment. And it is a renewable. I can use this source again and again, so it is not required anything for this free source. And it's also sustainable energy. It will comes every every day and every time, so it is not required anything. Basically it is a free source, and it is this system is having less maintenance. Like once you invested in that system, solar energy system, that in the operational that we have don't have the that high maintenance. It is having less maintenance, like very less, like 1 to 2% in the investment cost. And also it is significantly reduces the carbon emissions in the environment, because it is a green energy. It is not produce any carbon emissions, so it is free from the carbon emission. And it is also reduce the need to use the fossil fuels like coal, gas, and oil. So we are using sun energy, so it is don't require any coal, oil, and gas. So it will also reduce the fossil fuels, also reduce the. And for this disadvantage of solar energy, mainly it is having initial investment for this solar energy system is very high as compared to fossil fuels. It is very high compared to the fossil fuels, as well as the hydel power stations. Like it is having something like photovoltaics modules, and also inverters will contribute more than 60% investment for the project. And also it is having low efficiency. We can come to the thermal power plant. It will efficiency have like 70 to 90%. For this solar energy, it is like 12 to 24% only. For the wind, it is up to like 35%. And in some weather conditions, like if it will generate the low power, like in the rainy season and the raining is going on, so it will not generate that much as than one. And also in night times there is no sun, so there is no production of generation from the solar panels. So these are the basic disadvantages for the solar energy. And we move to the types of solar energy. Is types solar energies can be classified as a passive and active. So active solar means you can use this some mechanical structure, mechanical devices to collect or collect, to store the energy, or you can generate the energy. You can convert that energy into electricity or heat. So these are the active solar energy means, like you can use the everyday, like solar heaters, street lights, and as well as the solar panels and solar cooking appliances. Then passive solar energy, it will not use as that much, only for the some specific reasons that passive solar energy will not use it. It is contribute only 0.1% or 0.2%, because it will not use any mechanical devices or a mechanical structure for the collect the solar sunlight to use the solar energy. Like it is also produce the heat, but in a way that you can design the building like that. So, for example, you can design the building like that. So we can easily absorb the energy without any collectors or a mechanical structure. So it is not widely used. Only active solar energy is used widely used, and in that active solar energy, there is photovoltaic panels. It is widely used, and solar thermal collectors only they have a 2% contribution, and photovoltaic panels is having more than 80% contribution in the solar energy, and the rest of them are like residential commercial appliances like solar heaters and street lightings like etc. Solar thermal energy is the use the solar energy to generate the heat. It is a source, like it is like mirrors, so it will absorb the solar light, and it will turn that into the heat. So that heat you can use for the hot waters and use for the cooking, and so many applications for this heating. And also solar thermal energy you can use for the generate the electricity, and you can store that heat. You can use in nights also for the generate the electricity. That is another concept like CSP, concentrated solar power. And photovoltaic solar energy, it is photovoltaic. That means it is, once again, it is come from the Latin word. This photo means is photovoltaic means that is it is generating from the cell. It is generating electricity from the cell. That solar energy that converted to solar radiation, that once we observe at the sunlight absorbed at this earth surface, that convert into the electricity by semiconductor panels or cells. Nowadays, that is called PV cells or PV modules. That is photovoltaic modules. There is having different types of modules, and this technology is widely used for power generation. Like we are having in India now by 2021. We are installed power generation plants by solar PV system, like 150 gigawatt. In that 150 gigawatt, that like 30 gigawatt for these solar rooftop and conversion, and this remaining 70% is come from the ground mounted and floating solar. Like I said, this is solar thermal energy. That is also one another type of technology, that is concentrating solar energy. This is solar. This is you can call this as this third generation technology. Actually, these solar thermal and photovoltaic is just the first generation technologies, and second generation technologies will be the photovoltaic solar energy itself. But there is some modifications. There is some renovations done in the photovoltaic solar technology. So that is second generation, like that is a thin film solar photovoltaic solar cells. And this is concentrating solar energy. That means basically it is like mirrors. It is focused on the sunlight. It will be the having it will rotate in 180 degrees. So where the sunlight is directly get the perpendicular, so it will reflect like it is like sunflower. It will move as per the solar rays. So concentrated solar energy will collect that sunlight. It is that turns into the heat. That heat will be collected in the tower. That tower will that heat will generate the steam by using water or the salt, some different kind of that special type of salt. So that steam will drive the turbine to the provide electricity generation. Then this heat you can use for the generation, and also you can store this heat for during the nights. You can generate the electricity in night. And we come to the photovoltaic solar energy topic. Basically, photovoltaic energy, that solar electricity like solar panels or cells. So, we can know about the solar cell. Solar cell is a, semiconductor device that is having actually that photovoltaic solar energy is a DC type. So we were using that DC energy converted into the using inverter. We were converted into the AC. That AC power will use for the home appliances like for the power generation like transformers and substation. So solar cell basically it is like small one like it is having 6 micrometer thick solar cell, and it is having like PN junctions. Yet, like P has having high concentrated holes, and N junction is having N having the high concentrated negatives. So from that one, once so we can define the solar cell, how solar cell will work later. But we can first we will see the say solar cell history. So solar cells history is actually it is started in the Roman Empire. Like they use the solar energy for the cooking in that time. And first, actually, that photovoltaic effect is first invented by the Alexander Alban Becquerel in 1839. That is photovoltaic. That they he came to know that photovoltaic semiconductor will be the selenium. Selenium you can use as photovoltaic effect so that we can generate the electricity. In 1873, using that the selenium concept willing by Smith, they done the experiment on the selenium semiconductor. So they generate the electricity, and it is not fully developed. And in 1876, William Hills Adams and Richard Evans they also done the same experiment. That invented that Becquerel to selenium. So they have somewhat successful in the selenium as a semiconductor. And in 1883, Salas Frieds first provided the solar cell. They provided they invented the solar cell. It's selenium solar cell. So as compared to the nowadays, we are using silicon. Selenium is very much expensive than the silicon. So in 1905, Albert Einstein written the article about the photovoltaic effect in USA. In and the first patent given for the 1954, that is in before these solar cells there is a solar thermal energy is used from the 1880s. They are using that solar mirrors to collect the energy to generate the water heaters and use for the cooks. Like you can see these in 1906 also some residential solar heaters also available in USA. And 1954 at Gerald Chapman, Calvin Fuller, and Gerald Pearson, they invented the first solar cell using silicon. Basically, in that time, they need power electrical supply for these the space satellites. So for the off-grid satellites, so they required independent solar independent resources for the electricity generation. So they have done they have invented this solar cell using silicon in 1954, and now that they like they are using for that these satellites using this solar cell using this solar cell. This in that time that solar cell is very expensive in that time, like in 1964 one solar panel which 1 kilowatt hour solar panel which cost to $300. And in that time that coal thermal plants, that is one unit, that is 1 kilowatt hour, is cost only $6 to $7. So gradually that price will come down from the year after year. After 2005, that silicon prices and solar module prices has gradually decreased, and now in India we are in photovoltaic cell technology. We are already done the 150 gigawatt And first residential rooftop solar is done at White House in 1970. That is the first commercial solar system is installed. So we can check the working of the solar cell. Basically, that solar cell, it is having positive holes and negative electrons. And so the photovoltaics that having combines with the p-type and n-type semiconductor with different electrical properties, like we can say that n-type having high concentrated electrons and p region is having high concentrate holes. So that those two junction, we can call it as p-n junction. And once sunlight will reach the this solar cell, so it will form the p-n junction, and it will flow. That n-type semiconductor will try to flow through the p region and fill the hole like p-type connector, and that called as a depletion relation. Once the p-type n-type pair is done, that is called depletion relation, but it will not generate the electricity, because for generate the electricity for that for pair, we need to drive that pair to flow the electron. So for that one, when sunlight strikes the like in the solar panels, I basically on the top side of the solar panel we can use the non-reflective glass, so that we can gain the maximum power from the sunlight. When light strikes the cell and electrons in the n-type in semiconductor, will try to flow the pre-region and fill the holes. Like I said, this is like it is combined with the pace, and it will generate the depletion region. That depletion region, when light strikes that n side electrons, trying to reach the n side to uh, to flow the electrons from the n sides to p side. So it will generate the loop for the electric loop. So it will provide the electricity field. So this concentration of electrons at the n side and holes at p side increases. That potential difference between them is developed. Like when one sunlight strikes the n type and hole pairs, it is all called depletion region. So it will try inside electrons will trying to reach the p side to the load, and p side is it is reached to the p side junction. So in that one, once again we there is a one potential difference will be developed. That potential difference will drive that electrons to flow the electrons from the it will provide electrons to from n side region to p side through the load. So when you connected the load, that electrons will flow from the n sides to p side. So it will form the electricity field. How this is the how we can generate the electricity field. It is basically direct current, because you are using like holes is positive and electrons and the n type is negative. So it will provide the direct current, and it direct current we can converted into the AC through inverter, and that AC will connect to the home appliances like electrical bulb and LED lights like solar, uh, like iron box. So basically three types of generation and solar cells. Like I said, the photovoltaic cells is the first generation voltaic cells. In that photovoltaic solar cells, there is the three types of those solar cells, like monocrystalline silicon cell and polycrystalline silicon cell and multi-junction solar cells. So in second generation solar cells, it is called thin film cell. Like it is also come from the silicon, but that is you can use the micro silicons. Like I said, it's monocrystalline silicons. You can use the 80% of the pure silicons for the create cell. In that MAM purpose, it is just like 6%, 7%. And as compared to mono silicon cells, the thin film cell efficiency is very low, like it is 6%, 7%, and it will up to 13%. Thin film also, there is a different types of cells like MR thin film silicon and cadmium telluride and copper indium gallium selenium. This is the new generation type. It is in this copper indium gallium selenium is the new type of technology that is now it is in the uh, experimental mode. It is not comes into the commercial operations. And third generations, it is solar cells using silicon. Instead of using silicon, they are using some other materials like nanotube silicon wires and solar inks. Using that one, they process the solar cell. There is a five types of these things, and this is also uh, it is also not fully developed. It is also in the experimental in the experimental like DSSC. This dye sensitized solar cells, quantum dot sensitized solar cells, and organic photovoltaic and polymer hybrid solar cells, and perovskite solar cells. So these are the generations for the solar cells, and we will go to the first generation solar cells.